everyone, it's Miss Sinclair.
And Miss Shannon.
We wanted to do a review video for you about the discriminant.
Okay, so the discriminant is the part of our quadratic formula that is underneath our radical, b squared minus 4ac. And what this value tells us is the nature of our roots. So it'll tell us if we have real roots, are they non-real? If they happen to be real, are they rational or are they irrational?
Okay, so let's discuss what different values of the discriminant give us in terms of the nature of our roots. So if our discriminant is a positive perfect square, so if the b squared minus 4ac is a positive perfect square, like 25 or 36, our roots are going to be real, rational, and unequal. If our discriminant is a positive non-perfect square, so 11, 17, 20, our roots are real, they're irrational, and they are unequal. So looking at what it would look like on the graph, there are two x-intercepts. So it's going to go through the x-axis twice. If our discriminant is 0, so b squared minus 4ac equals 0, our roots are real, rational, and equal. We still have two roots, but they're equal roots. So what this means is there's only one x-intercept. So your graph would look like this. Your graph is tangent to your x-axis. If our discriminant is negative, so if b squared minus 4ac comes out to be a negative number, our roots are imaginary, which means that we have no x-intercepts. So your graph might look something like this.
Okay, so now we're going to take a look at some Regents questions talking about the discriminant. So for question 1, they're asking us for the nature of the roots. So once you see this nature of the roots, that's what the question is requiring you to look at. That means you're using your discriminant, which is b squared minus 4ac. So we need to think about what is a. In this case, we have an a of 1, b is negative 1, and c is positive 1. So if we just take a look at what that would be, if we typed it into our calculator, b squared minus 4ac, we'd get a value here of negative 3. So since we have a negative discriminant, our roots are going to be imaginary. Question 2 is asking us the same thing, nature of the roots. So now if I take a look at this quadratic, I have an a value of 4, a b value of negative 4, and a c value of positive 1. So again, if I type those values into the calculator and use b squared minus 4ac, in this case I get a value of 0. When my discriminant is equal to 0, my roots are going to be real, rational, and equal.
Okay, so let's look at two more questions. So here we're asking again the nature of the roots. So I know I need to use my discriminant, x squared minus 2x equals 5. I need to bring that 5 over to the left. So really, it's x squared minus 2x minus 5 equals 0. So a is 1, b is negative 2, and c is negative 5. So when I put that into the b squared minus 4ac, I get 24 as my discriminant. 24 is a positive non-perfect square, so my roots are real, irrational, and unequal. Choice 4 in this case. Let's look at this one. Again, they're asking us for the nature of the roots. 2x squared plus 8x minus 10. My a is 2. My b is 8, and my c is negative 10. Put it into the b squared minus 4ac. I get 144, which is a positive perfect square. So my roots are real, rational, and unequal. Choice 2. Okay, so this question is asking us which graph represents a quadratic function with a negative discriminant. So they're telling us that b squared minus 4ac value is negative. Well, we know that means our roots are imaginary, which means that our graph does not cross the x-axis at all. So our graph would look like choice 4.
Okay, for number 6, it's asking us which value of c would make the roots of our equation real, rational, and equal. So in this case, I have a discriminant that should be equal to 0 if my roots are equal. So that means the b squared minus 4ac should be equal to 0. So based on this quadratic, I have an a value that is 1, a b value of 6, and c, right now, I don't know. That's what we're looking for. So let's plug in what we do now. 6 squared minus 4 times 1 times c should be equal to 0. So we get 36 minus 4c is equal to 0. If I add over that 4c, I get 36 is equal to 4c. If you divide by 4, you get a c value of 9. So in this case, if that constant value is equal to 9, that's going to make our roots real, rational, and equal. Okay, for question 7, it's asking us what is the greatest value for c for which the roots of the equation are real. So now we're just talking about real. They could be equal, they could be unequal, they could be rational, they could be irrational, but we want them to be real, which means our discriminant needs to be greater than or equal to 0. So b squared minus 4ac needs to be greater than or equal to 0. So again, I need to take a look at my quadratic and look at my a, b, and c values. So I have an a of 1, I have a b of 4, and again, they're not giving me a c value. That's what I'm trying to find. So if I take 4 squared minus 4 times 1 times c, what would make that stay greater than or equal to 0? So 16 minus 4c. If I add over the 4c, I get 16 is greater than or equal to 4c. If I divide by 4, I end up with 4 is greater than or equal to c, which if I want to read this from left to right for the variable, it would be c is less than or equal to 4. So the largest possible value here for c would be, if c is equal to 4, that's the largest value that would make my roots real.
So for our last problem, they're asking us for which value of k will the roots of x squared plus 2x plus k equal 0 be imaginary. So in order for the roots to be imaginary, the discriminant needs to be less than 0. That means our b squared minus 4ac needs to be less than 0. So we can list our a as 1, b is 2, and c, again, we're not sure. So 2 squared minus 4 times 1 times, I'm going to put k in, has to be less than 0. So 4 minus 4k will be less than 0. Let's move that 4k over and divide by 4. So 1 has to be less than k, which means k has to be greater than 1. So the only choice out of these choices they gave me in which k is greater than 1 is choice 2.